Hey guys, today's video is all about types of chemical reactions. And then at the end of this video, I'm going to do a few demos, okay? So first thing is in class, we made like a foldable. You can try to make this at home. All you need is a blank piece of paper. And then we cut it into 1, 2, 3, 4, 5, 6 strips like this. Or there's an example over here on this side. So we folded it hot dog style, cut out these strips, and I wrote the types of chemical reactions at the top, and then synthesis, decomposition, single replacement, double replacement, and combustion. On the inside part, we just put the actual definitions here. So we put definitions here. And then on the outside, we just had this kind of A plus B makes AB, and so on and so forth. So I'm going to go through all of these things today. You can make a foldable as part of your notes. You could also just type up kind of the gist of it on a Google Doc. That would be totally fine. Or you could take notes like on pencil and paper and then just take a picture of the notes that you make, okay? So that is your notes part. Okay, so there are 5 actually different types of chemical reactions. We can kind of sort them into this category. There's synthesis, and we're going to represent these by looking at some letters. So the letters each represent they don't represent each other. They represent an atom or a molecule, and in synthesis, A and B here are going to combine together, and they're going to make a brand new thing, AB, okay? So we also like to call this the soap opera of chemistry. So we're gonna lay this out like a story, okay? So here, A and B, they meet, they fall in love, one thing leads to another, and they are a couple now. So A and B are together, they are a couple. Yay, this is the honeymoon phase. All right, and then decomposition, A and B together, this new compound, and things aren't looking so great. They have a separation. So decomposition, A and B separate, and A plus B, they are apart now. So now we are back to having, again, if we think about this in terms of chemistry, then we have a compound and it breaks down into its 2 basic units. Then we have single replacement. Just like it sounds, A and B are together. Maybe they're trying to work things out. And then in walks C. Oh man, all right. This isn't C's fault. Okay, let's just keep that in mind. It's really A's fault for completely getting rid of B and then coming over here and forming a new relationship with C. So B is left by themselves, but not really by themselves because they have great inner strength. And A and C are together now. B is over here, off to the side. By the way, I'd like to point out, I describe this like this every year. Like my life's okay. And then we have double replacement. We have A and B together, C and D together. And they do, actually, I like to pause on the relationships one. I like to describe this like the movie The Parent Trap. So, oops. Not that one. Not that Parent Trap. Okay, so if we look up this movie, hopefully you guys have seen this movie. All right, was it the height of Lindsay Lohan's career? Possibly. In the movie The Parent Trap, which was adorable, these 2 twin girls have parents that got divorced, they split up, and each parent took one of the twins, and when they find each other at summer camp, they decide to switch places to hopefully make their parents fall back in love. So this is kind of like that movie. So we have A and B here. So we've got one twin with one parent, one twin with the other parent. And when they switch places, everybody is they're still family. They're still like all 4 together. But now they have switched. So A is now with C, B is now with D. If we're talking about our relationships in terms of our soap opera, then you could think of this as like a swinger day. So enjoy that. And then for our 5th type of reaction, we have combustion. I tried to fit as many combustion pictures on here as possible, but essentially combustion is whenever you produce heat and light from any kind of fuel source. So fuel sources include different chemicals, different like fires here. These are the trees, fireworks, etc., etc. And in combustion is actually a really specific equation. So we're going to talk about that. All right, so here are your definitions for these things officially. In a synthesis reaction, reactions combine to make a single compound, one thing. In decomposition, reactants break up into different products. Notice that in the product of a synthesis reaction, so the end result there, might actually be the beginning of a decomposition reaction. So it doesn't necessarily matter that one is like one whole thing, and then the other chemicals. So if we go, actually, let's just do that. Hide this one. There's too many things. Okay, so if we look at the synthesis and the decomposition, we see these two things coming together, A and B, to form AB. So notice how this product is the same as this reactant set. So it doesn't matter that this is more complicated. That doesn't automatically tell you where to put it. A reactant is just whichever goes first, and what yields is whatever forms at the end. So these might well be like the same thing, and that's okay. Okay, combustion is whenever we have a fuel. So we're talking about fuel. We're going to talk about hydrocarbons specifically. Hydrocarbons are just carbons and hydrogens put together. Everything that is alive, everything that's organic, is made up of hydrogens, carbons, and oxygens, with a few other elements thrown in there, but those are the bulk of it. And so everything that has hydrocarbons is flammable, right? And so if we think about things that we burn for fuel, most of them are going to be previous living things, things that have now died or things that have been cut down. So we think about burning plant material like leaves and sticks and wood, and we're thinking about burning dead plants, and those are all made of hydrogens and carbons. If we think about burning coal or different types of oils, if we're talking about like car oil, then we're also talking again about things that used to be alive. And because they used to be alive, they're going to be made out of carbons and hydrogens. Now, all this fuel needs is oxygen gas, which is 20% of our atmosphere. So it's floating around in there. And they're going to create three things. Well, kind of four things. One, they're going to make light or heat. And we're going to see this in the form of a fire. They're going to make carbon dioxide gas. They're going to release a lot of that in the atmosphere. And then they're also going to make not oxygen gas. They're going to make water vapor. I don't know why that's wrong. I'll fix that. So they're going to make water vapor, and they're also going to leave behind some sort of residue in the form of ash or soot. Whatever is left in that compound that did not burn up is going to be left, and it's going to be a much smaller physical thing. In a single replacement reaction, an element takes the place of a different element in a compound. And in a double replacement, replacement and displacement are sometimes used interchangeably. I prefer replacement personally, so I'll probably have to fix that too. Double replacement reaction, elements and two reactants switch places. Okay? You could also model this way. So we use color pencils and pens in class to kind of draw this out with colors. I think that colors kind of help a little bit. That A and B are forming together, A and B are breaking up. A and B and C, B gets switched for C, and then in this one, all of them switch partners. Okay, so now I'm going to go over some of the demos I did in class. So let's actually make this,